Okay, so today we're going to look at factoring trinomials. They're not quadratics, but we're going to pretend they're going to be like a quadratic form, right? If you looked at this week's PowerPoint presentation and kind of reviewed the steps for how to factor, we're going to do all that same stuff. If you didn't, go back to the little mirror board that had a PowerPoint embedded in it on factoring and click the little button that says I do not remember how to factor, and then pick one of the three factoring methods. There was grouping, box method, slide divide. Now with the end of this week's stuff, slide divide isn't going to work with the really big ugly things. We're not going to be able to do it the same way. The other two, box method is going to work for some of them, except for the really ugly problems. Grouping is going to always work, but it's like the least friendly of the three. If you learn slide divide and grouping, and can kind of do grouping, you can save it for the hard ones. I don't know. You pick your poison. Slide divide's the fastest for the actual trinomials. Box method is second fastest, but it also works for the 4-piece polynomials, nothing else. Grouping is the slowest, but always works. Alright, today they're just trinomials, so you can do it whichever way you like. You can build another skill in the future if you'd like. It's okay. I mean, I learned how to do all of them. Alright, there's two ways we're going to do this. And you have to decide which one you like better. Okay, you're either going to write out a substitution so that you actually have a quadratic that you can factor, or you can just remember that's going to be kind of quadratic form. I'll show you a little bit of both of them here to show you what we're talking about. So if I have 6x to the 4th minus 18x squared minus 324, this guy is ugly, right? First thing, always look and say, do they all have something in common that I can take out? And surprise, surprise, they do. That's not the color I wanted. This will work, right? 6 goes into 18, so that's good. 3 plus 2 is 5, plus 4 is 9, so 3 goes into it and it's even, so 6 goes into all of these. So I'm going to take out a 6, and be left with x to the 4th minus 3x squared minus 6 goes into that, 5 times 4, 54, right? So now we have that. Now it's a trinomial. If it's a trinomial and the exponents go down by the same amount each time, it's going to be factored. That's one way I look at it. Also, if this guy, after I've taken out everything they have in common, they all have an x, take out the x. If this guy is half of that guy, it's worth trying factoring because it's a trinomial. Alright, the first thing I'm going to do is look and say, okay, I'm going to just pretend it's a trinomial. It's a regular, like a quadratic. In fact, I'm even going to do the slide divide. Alright, this guy, pretend this guy's been factored. We leave him alone, take him off to the side, pretend he's not there for a minute. We have a 1 in front and 54 at the end, so my factor list is for 1 times 54, which is 54, 54 and 1, 27 and 2, 3 goes into it, what, 18 times? Is that right? 24, yeah, okay. 4 goes into it, no it doesn't, that's a 27. 5 goes into it, 6 times 9, 7, 8, yeah, that's it. Yay! Alright, so looking for which factors, subtract, to give me 3, that's those, right? And when I put these two together, I have to have a negative 3. So I'm going to make him a negative and him a positive. Yay! Alright. I'm still a slide divider. If I have just 3 pieces, I'm going to slide divide. I'll do the next one a different way, just so you know. Minus 9 and I take this guy right there. That's not true. We usually put him with nothing, right? Because he has to be a pure number. Alright? Ignore what I said about that guy. I'm not starting this whole video over. I'm tired. Alright, there's a 6. Alright? I take this guy, and that type of variable goes in the front. That's what I meant to say. That one right there. And divide by whatever's in front of the 1 of this guy right here. Not the 6. Inside that parentheses with that first thing. And that's just a 1, so they're all over 1. We're good. We would be finished. And this is where you're going to really hate these. Because, you know, polynomial means many. For us, it means many steps until you're done. Alright, that 6 is a factor. This guy, he's not a perfect square. That's a sum. He's not a perfect, he is a perfect square, but that doesn't help me out. He's pretty much done. That's a perfect square. That's a perfect square. That's a difference. So, like earlier this week, we know 2 sets of parentheses. Square root of him is x. Square root of him is 3. And put in different signs. That one's factored. This guy comes from up here. That's x squared plus 6. He can stay in the back. And that 6 comes all the way down. Now I have fully factored that polynomial. Yay! Ready? Round 2. Alright. Oh, green is not the color to use. X to the 4th plus 3x squared minus 18. Alright. On this one, I'm not going to do slide divide. I will do box. Alright. Now, I'm also going to do substitution. Substitution is I look at it and say, man, I really wish that was just an x. Right? Because then I can see that this is a quadratic. So what I'm going to do is pick any other letter just to keep you from aggravating. My second favorite letter is y. So I'm going to let y equal x squared. Alright, I'm going to make this in a little box. Don't forget to go back to this. And I like it not being an x because when you finish, you shouldn't have having x's everywhere. And if that is not an x, if this is not an x, it'll kind of remind you, hey, I'm not done yet. Alright, so x squared times what is x to the 4th? Or how many x squareds does it take to get x to the 4th? Another one, right? X squared times x squared. Well, that becomes y squared, right? Show what I mean. X to the 4th equals x squared times x squared. Y'all okay with that? Alright. Each x squared is a y, so it's the same thing as y times y. And y times y is y squared. Alright. So I have y squared plus 3 x squared. Well, x squared is just y minus 18. Now it's a quadratic. Yay! Now we can go to our box method, which still needs a factor list. That's never going to go away. 1 times negative 18 is just negative 18. Some people like the whole x thing again. I don't really like the x. 18, 1, 9, 2, 6, 3. I think that's it. They have to subtract to 3. That's those two. Positive 3 when I bring them together. So it's plus 6 minus 3. That would give me positive 3. And I get to go to the box. Remember, I'm only doing this fast because you already saw this explanation in the PowerPoint that you're going to go back to and review from yesterday. Okay. Y squared goes in the first box. Negative 18 goes in the last box. I have a 6y in one box and a negative 3y in another box. Factor up, factor left. Steal signs. Don't fall. Positive, 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 negative. Factor up. 6y and negative 18. All they have in common is a 6. y squared and negative 3y, all they have in common is a y. Here, all they have in common is a y. Writing sideways, don't let that mess you up. And here, they have the negative 3. So, that leaves me with y plus 6 and y minus 3. Now, I am not finished, because each y is really an x squared. So now I go x squared plus 6. Does that factor anymore? Not nicely. And y minus 3 is just x squared minus 3. That 3 is not a perfect square, so I'll leave it alone. And now that is that one. Are we finished? No! We're not done. I have to show you how to do it with grouping. Am I too loud? Oh, sorry. I may have just woken up my daughter. Number 3. We're going to do this one with grouping. Do you want to substitute? No, that's not a substitute. No sub. Alright, so 6x to the 4th minus 10x squared plus 4. This guy's half of that guy. We're going to be good. He's going to factor, well, he's going to at least have a chance of factoring. Factor list. 6 times 4 is 24. Factor list, first times last, don't forget that. Make a little list, 24, 1, 12 and 2, 8 and 3, 6 and 4, that's it. They have to add to negative 10. Why is it always the end of the list? Alright. I promise I didn't pick these out on my own. I'm going to do this one through grouping, right? So now I'm just going to keep that guy, 6x to the 4th. What I'm doing is rewriting this negative 10x squared as those two things. I'm undoing math. Alright? So they have to add to negative 10, so they're both going to be negative. So it's going to be minus 6x squared minus 4x squared plus 4. Colors make grouping so much easier, by the way. Where's my black marker? I lost it. Okay. Like, I seriously lost it. Okay. Oh, there it is. So, we're here. We're now going to make two couples. They're going to add. Alright, and let's see what these couples have in common. Well, here, those both have a 6. They can talk about 6. That keeps them interesting. Yeah, they're not interested in that. They both have an x squared, so they can talk about that. But when this guy and this girl, I'm putting the guy first just because, you know, I don't know. Okay, so, because he's purple. Okay, so this guy, when he's talking about 6x squared, he has another x, oh, that's the wrong color. He has another x squared inside him. That's just being left out. And this girl, when she's talking about 6x squared, she has that negative 1 not being talked about. It's just not being, those needs are not being addressed. So here, this couple, when they're looking, when they get together, what they have in common to talk about is a 4. I'm going to take out that sign. Why? Because I always take the first sign. Well, this one's positive, so I take out a positive. This one's a negative, so I'm going to take out a negative 4. Right? And now watch. So this couple's going to be talking about a negative 4. And when this person, this being, is talking about a negative 4, they feel that x squared is just getting left out. And this one, when this person is talking about a negative 4, they have another negative 1 inside them being neglected. So, the reason why this is a 4 couple thing that works out just fine, when they get together, now look, these two sets of couples, they both, the leftovers, have an x squared minus 1 in common. It's almost like two couples, guy, girl, right? They all end up being friends because they have lots of stuff in common, but he likes to fish, and he likes to fish. Neither of them do. So they end up becoming friends. They go fishing, and they go shopping or something? I don't know. I'm trying to think of things that have made me get through everything. You people that are seeing this on the internet from a search, I come from a very, very rural, southern country area. Please don't make fun of me. I'm making analogies to make the most sense for my students. I really don't care what you think about me. What I care about are what my kids think about me. Actually, I don't even care if they think about me. What I do care about is, does the math make sense to my kids? So if you don't like anything I'm saying, get over it. All I care about is my kids being able to pass my test and do math well. Alright, so there we go. I've used all the stereotypes I can because it makes sense. There's a reason why there's stereotypes. Alright, x squared minus 1. And now my leftovers, so if I take out this x squared minus 1 from this group, well, what's left over is a 6x squared. And if I take a x squared minus 1 from that group, what's left over is a minus 4. You would think I was done, and you would be wrong. Because, now, this is not technically a difference of perfect squares, because that 6 is not a perfect square. We can factor out a 2, because way back here at the very beginning, I should have taken out a 2, because every single number is even. Shame on you for not stopping me. I am tired. I'm exhausted. It's been a long week, and the week's not even over. It's not even close to being over, right? So, you should have stopped me here. But you know what's nice? That will kill you. Slide divide, you'll end up losing answers, it'll be gone. Box method, you'll end up getting the wrong answer, and you'll be done. With grouping, if you forget to take out that common guy early, you'll be alright. You'll get something like this that screams, they're both even. Okay, so I'm going to take out a 2. Actually, I'll move the whole thing in front. That's going to leave me 3x squared minus 2. No perfect squares. We'll leave that alone without factoring it. This guy, however, he is a difference of perfect squares. Please don't forget that 1 is a perfect square. He's neglected. He is a perfect square. So the square root of x squared is just, so x in front of both, different signs, and the square root of 1 is still 1. And now I have finished that one through grouping. Marker drop. It's my version of the mic drop. Alright, we have time for one ugly problem. You ready? You're gonna hate me. But then again, I've used like almost 20 minutes of your time, and that was kind of the goal. If I'm not giving you practice problems and just making you watch stuff, I'm going to use up all your 20 minutes. Alright, ready? So, first, because I'm not going to get burned again, check for anything common. Oh, 39 is not prime, but it should be. It's 13 times 3. 3 doesn't go into 40. They have nothing else in common. Alright. Check this out. Alright, so nothing here. So let's go slide divide. It's fun. First times last is 9 times 40. 9 times 40 is 360. Factor list. They have to add up to 39. 36 and 10 doesn't do it, because that adds up to 46, which means they have to be closer together. 12 goes into it. 12 times 30. That is not at all true. Yeah, it is. Have to get more than that. What about 15? 15 goes into it. Um, 5 and 2, 24. If I lost my pride and decided to God bless me. 24. That's 39. How about that? Alright, slide divide. With these numbers, that's what I'm definitely doing. X to the 4th. This guy goes in front. It's going to be in the pain. They add up to positives. 24, 15, over 9, over 9. Reduce, reuse, recycle. 24 has a 3 in it. It's 3 times 8. So, and 9 has a 3 in it. And 3 in there. 5. I don't know why it's called slide divide. It should be called divide and slide. So now I'm going to slide the 3 up there and have 3x to the 4th plus 8. No perfect squares, no perfect cubes. That's a perfect cube, but that's a perfect square. That's not either, so we're good. And 3x to the 4th plus 5. And now we are done. Alright. If you want a little bit of extra credit in the class, I need you to today, not tomorrow, not any day, today, email me the word pickles. Pickles. That's a K. And bad handwriting. Alright, that was it.